Hello everyone. So this is a question from JEE Mains 2026 8 April Shift 2. Consider the following reaction. So we have an organic compound and there are a few reagents, that is NaBH4 in the presence of CH3OH, MeOH. Second is NaOH aqueous and heat. Third is H3O plus and we are getting P. The major product P formed is, okay. The chapters involved is aldehydes, ketones and carboxylic acid. So our given organic compound is first subjected to NaBH4, that is this guy, sodium borohydride, and that too in the presence of MeOH. In MeOH, Me stands for methyl, so this guy is CH3OH. So we have NaBH4 in alcohol. We have two famous reducing agents. One is LiAlH4, which is lithium aluminum hydride, and NaBH4. LiAlH4 is a much more powerful reducing agent than NaBH4. So this is more powerful than NaBH4. Okay. So LiAlH4 can reduce many organic compounds. For example, aldehydes, ketones, acids, acid chlorides, esters, amides. Okay, important. LiAlH4 can reduce amides also. It can reduce anhydrides, nitriles, oximes, alkyl halides, and nitro compounds. But NaBH4 reduces, it's weaker compared to LiAlH4, so therefore it reduces only aldehydes, ketones, and acid chlorides. Very important. So NaBH4 reduces only aldehydes, ketones, and acid chlorides. So in our starting organic compound, that is this guy, we have two functional groups here. Okay, a carbonyl group, that is this carbonyl group, linked to a nitrogen. So this is the amide group. This is the amide functional group. Okay, and a CHO group, that is this group, C double bond O H, which is the aldehyde group. Okay, cool. And since our first reagent is NaBH4, in the presence of alcohol, it won't affect the amide group. It won't affect this group because I have already mentioned that LiAlH4 can reduce amides, NaBH4 cannot. Okay, so therefore NaBH4 won't affect this amide group, but it will reduce the aldehyde group to a primary alcohol or a 1-degree alcohol group. Okay, that is, so important statement. NaBH4 won't affect amide group, but it reduces the aldehyde group to 1-degree alcohol. So therefore, our starting organic compound will be converted to everything else will remain same. So instead of the CHO group, we have a primary alcohol group here. Okay, cool. And the second reagent that we use is NaOH aqueous in the presence of heat. Okay, and amides in the presence of NaOH aqueous and heat undergo base catalyzed hydrolysis. Very important. And ultimately gives the corresponding carboxylic acid salt, and the other product depends on what N is attached to. Okay, so I will write that down first. Amides in presence of NaOH aqueous and heat undergo base catalyzed hydrolysis, giving corresponding carboxylic acid salt and other product depends on what N is attached to. Okay, that is, for example, it depends upon what this N is attached to. Okay, so I will give you an example to understand. So let's say we have, amide group. Okay, so here we have the carbonyl CO connected to N, therefore this is the amide group, and this N is connected to, let's say, some groups. So in the presence of NaOH, and obviously aqueous NaOH in the presence of heat, so this bond is going to break. This bond breaks. Okay, so that's how we get this part will give us the corresponding carboxylic acid salt, and this part will give us the other product. Okay, so the one of the product is, this is the carboxylic acid salt, and the other product is N, which is connected to the respective groups, and one H will be connected to this N. This is the other side product. Okay, and the mechanism of this reaction involves three steps. It is important to know the mechanism. So it involves three steps of this reaction. Okay, the first step is nucleophilic addition of OH minus to carbonyl carbon. Okay, so basically this OH minus is going to attack our carbonyl carbon. Okay, to show that, I will draw the amide group once again. So since it is the carbonyl carbon, it will bear a partial positive charge. This O will bear a partial negative charge. So I will give those charges. And the OH minus from Na plus will come and attack our carbonyl carbon. And because of that, these one of the pi electron or the pi bond will become a lone pair. Okay. So we will get CO obviously will have a negative charge on this oxygen because these electrons are transferred in the form of lone pair, and OH will form a new bond with the carbonyl carbon and nitrogen, and you can see the hybridization has changed from sp2 to sp3. This is the first step. Okay, second step is elimination. So in elimination, this any one of the lone pairs will come and form the double bond back, and nitrogen will take this sigma electrons and in the form of lone pairs. Okay, so we will ultimately, using arrows, this will come back here, and this sigma electrons will form lone pair on the nitrogen atom. So we will get C double bond O and OH and plus N. N already had a lone pair. Okay, so this time N will have two lone pairs. That's why there will be a negative charge on nitrogen. And the third step is deprotonation. So in this step, the carboxylic acid, that is this guy, loses a H plus to this nitrogen because it carries a negative charge. So it is desperately looking out for protons. Okay, so using arrows, so basically nitrogen with a negative charge goes and attacks the acid, and acid, it can easily liberate H plus. So therefore, using arrows, this takes this H, and oxygen, just to show, oxygen takes these electron pairs and bears a negative charge. So we get, upon deprotonation, C double bond O negative charge, and nitrogen will have form a bond with H and two other groups, and it will have a lone pair. Okay, and if you remember, there was a Na plus in the beginning because we are adding NaOH, right? So there will be a Na plus. So therefore, that Na plus comes and combines with the carboxylate anion to give us the carboxylic acid salt. So therefore, we'll end up with the end products will be C double bond O Na plus N lone pair connected to one H and two other groups. Okay, this is how the basic or base catalyzed hydrolysis of amide take place. Okay, in our case, the functional group that we got after first after the application of first reagent is this guy, C double bond O. Okay, and this in the presence of NaOH, aqueous and heat. So this will be converted to, so obviously this bond is going to break, the CN bond is going to break, and this part will give us the corresponding carboxylic acid salt, and this N upon the breaking of this bond will be connected to one H. So therefore we will ultimately get, let's give them numbers, 1 2 3 4. So we will get C double bond ONA, C1, C2, C3, C4, which is connected to N is connected to CH, CH3, CH2, OH, and obviously one H will come and it will have a lone pair. Okay, and then the third reagent that we are using here is H3O plus. So we are doing acidic hydrolysis now, and acidic hydrolysis of a carboxylic acid salt, okay, because it's a carboxylic acid salt, instantaneously gives the corresponding carboxylic acid and a metal salt. Okay, so therefore this guy will, upon acidic hydrolysis, will give us the corresponding carboxylic acid and a metal salt. Okay, so we will get ultimately, so this will be converted to OH, so we'll get C double bond OH, and then we will have CH2 C1, CH2 C2, CH2 C3, CH2 C4, connected to NH, which is connected to CH3, and that is connected to CH2OH, and also the other side product will be Na and OH. Okay, so the final answer, that is the major product P, is this guy. This is the final answer. Okay, thank you.